Hi students, today we are looking at the lesson Irrational Numbers. Your learning target is I can estimate and compare irrational numbers. Go ahead and write that down in your planner. And all you need today is your vocabulary journal, a pencil, calculator, and these notes or your book. If you are allowed to write in your book, you're allowed to follow along in your book with me. If not, just take the notes on this note sheet. All right, so we are starting on page 23 if you're following in your book, and we need to talk about irrational numbers. And the definition of irrational numbers is right here. You need to copy this in your vocabulary section. Irrational numbers are numbers that are not, and believe it or not, the answer is rational. Now, we've talked about what rational numbers mean in the past. Rational numbers are numbers that can be written as a fraction, like 3 over 1, or 1.2 can be written as a fraction. Any numbers, I call them normal numbers. They're rational, they can be written as a fraction, and this is your next blank right here is fraction. Okay, and so irrational numbers cannot be written as a fraction, and we're going to go through a few examples of numbers that actually can't be written as a fraction or as fractions, so that you can see some examples of rational numbers. The most common irrational number that you will see are square roots like this, and we've talked about numbers that are perfect squares. I'm going to go ahead and write them in case you've forgotten. So I'm doing 1 times 1 is 1, and 2 times 2 is 4. So 1 and 4 are perfect squares. Okay, so go ahead and write them down the side of your page. I'm going to do the same thing also. All right, I finished writing them all out, and these numbers are my perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And they keep going all the way up through all of the numbers, but these are the most common ones that we will be working with. Okay, let's go ahead and move on. The question on page 23 is asking you to estimate the value of the square root of 2. And here are the steps that you need to complete this problem. First, you have to ask yourself, which perfect squares is 2 between, the number 2? Which one is that between? So you look at these numbers here. Let me get a different color. You look at these numbers, the 1, the 4, the 9, all these, and you ask yourself, which one is 2 between? Is it between 1 and 4? Is it between 4 and 9? Is it between 16 and 25? Just like a normal number line, 2 is between 1 and 4. So your answer right now, or for that first step, is it's between 1 and 4. And if you're filling out your book, this is your first blank. It's at the first blank on the top right corner. So the square root of 2 is between 1 and 4. And we're using these inequality symbols to show that 1 is less than 2, which is correct, and 2 is less than 4, which is also correct. All right, so 2 would be like right here if this was a number line. All right, so then what we need to do is create an equality. So we're going to take the square root of each of these numbers, and we're going to keep these inequality symbols. So we're going to do the square root of 1 is less than the square root of 2, which is less than the square root of 4. Okay, now as a side note, I call this step right here, I call this an in-betweenie, and I put the word right here. It's not a real word, it's a made-up word, but this is what I call it. It's an in-betweenie because you're putting the 2 in between the 1 and the 4, or between the perfect squares. In this case, it is a 1 and a 4. Okay, so the next step we need to do is simplify the perfect square. So what is the square root of 1? I'm going to draw an arrow through my word, sorry, but the square root of 1 is 1. We don't know what the square root of 2 is, so we're just going to leave it as the square root of 2. But we know what the square root of 4 is. The square root of 4 is 2. So we know from this process that the square root of 2 is going to be greater than 1 but less than 2. Or 1 is going to be less than the square root of 2 and the square root of 2 is going to be less than 2. This is an in-betweenie. It's saying that the square root of 2 is going to be in between 1 and 2. So sometimes on your homework, this will be your final answer. This will be, it'll say which two whole numbers is this perfect square between, and this will be your final answer. But this one is asking you to estimate the value of the square root of 2. If we're asked to estimate the square root or the value of an irrational square root right here, we need to do this process that I call guess and check. So what we do is we know that the square root of 2 is between 1 and 2. So I like to grab my calculator and I do this. I do 1 times 1 is 1. Okay, easy. Then I do 1.1 times 1.1 is 1.21. Okay, so now I need to write that down. 1.1 squared, which is what I just did, is 1.21. Is 1.21 greater than 2? No, not yet. So we need to keep going. And when we're doing this, you're basically just taking any numbers that are between 1 and 2 and you're squaring them to see if you can get close to 2, as close to 2 as possible. And instead of going 1.1, 1.2 in order, I'm going to jump right up to 1.5 and just see if that one works. 1.5 times 1.5 is going to give me 2.25. Okay, so that's a little too big. Let's write this one down so we can keep track. 1.5 squared was 2.25. So that's a little too big. This number is greater than this. So we know that 1.5 is going to be too big. We need to make it smaller. So let's find out. Again, let's maybe go down to 1.3 and try 1.3. This is why it's called guess and check, because you can just keep trying numbers until one of them is pretty close. So 1.3 gives us, 1.69, so that's good. It's very close. 1.3 squared, oops, that's a little too, gives us 1.69. Let's see if we can go any higher. Let's try 1.4 and see if we can get closer to 2 without going over, because 1.5 already went over. 1.4 times 1.4 gives us, 1.96. That's very close. So I'm going to try to squeeze that in right here. 1.4 squared equals 1.96. Okay, so now do you see two more numbers on this side? This is still, like these numbers over here were in red. I'm going to keep this in red also. Do you see two numbers in this list that 2 is between? That the number 2 is between? It's right here. 2, if you were to put this in a number line or line them up from least to greatest, 2 would go between 1.96 and 2.25. So now for your final answer, you can say that the square root of 2, and this is on your page also, the square root of 2 is going to be in between 1.4 and 1.5. Because it's between 1.4 and 1.5. So your book actually tells you that it takes the average of these two numbers, and it says that 1.4 plus 1.5, and then it takes the average of the two, so it does this. And this is really just up to your teacher how they want you to do this. And so they added those two, and then they divided it by 2, and they get 1.45 for their final answer. So they say the square root of 2, I'll write this right here too, the square root of 2, and then they do this fun equal sign. It's a little curly one. I put a little note right here. It means approximately. So the square root of 2 is approximately 1.45. Okay. So that is your final answer for this problem. For me, I personally am okay if you just get to this step right here, because I think that this is it's the most accurate answer you can give. Okay, so take a break if you need to. We have one more thing to go over after this, and that is comparing irrational numbers. Before you move on to that, if you want to start your practice, this goes along with what we just learned on page 23. It's questions 1A and 1B at the bottom of 23, and it's asking you to make a better estimate of the square root of 2. So you can pick up right where we left off right here and see if you can find an even better estimate for this number. And then 1B is asking you to do that. 1A is asking you how you would do that. If you can't write in your book, feel free to write your answers down here on the bottom or on the back of this note sheet. Okay, so moving on with comparing rational numbers. Comparing rational numbers is very similar to what we just did. And we're going to go ahead and start on example 2, question A. And that is right here. The square root of 3 plus 5 is something to 3 plus the square root of 5. So we need to first estimate the square root of 3. So you can estimate the square root of 3. We can go back up to our perfect squares list, and 3 is going to be between 1 and 4 again. So the square root of 3 is going to be between 1 or the square root of 1. Let me erase that. Ooh, that's weird. So the square root of 3 is going to be between the square root of 1 and the square root of 4. So we know that the square root of 3 is going to be between 1 and 2, just like the square root of 2 was. All right, so it's going to be between 1 and 2, and instead of, oops, I wrote the wrong number again. Instead of writing, that's so funny. Instead of writing or doing a very close approximation, we're just going to really estimate, this square root sign should go away too. I'm sorry. Perfect. Okay. Sorry. So 1 is less than the square root of 3, and the square root of 3 is less than 2. That's what it should say. Okay. So instead of using the calculator and trying to get really close to the square root of 3, we're just actually going to say, take the average, and we're going to say 1 plus 2 is 3. Divide that by 2, and you get 1.5. So 1.5 is about the square root of 3. So then we're going to take that, and we need to add it to 5 based on our directions. So 1.5 plus 5 is 6.5. Okay, now we need to compare that to the other side, and that's right here. So 3 plus the square root of 5. The square root of 5 is going to be between which two? This time it's going to be between 4 and 9. It would fall right here. So it's going to be between 2 and 3, because the square root of 4 is 2. So it's going to be between the square root of 4, the square root of 5, and the square root of 9. So we know that 5 is going to be between 2 and 3. And then what we're going to do is just take the average. 2 plus 3 is 5. Divide that in half. That's 2.5. And 2.5 plus 3, right here, because we have to add it per the directions, is 5.5. So now we have 6.5 and 5.5, and it's asking you which one is greater. And it goes this way. 6.5 is greater than 5.5. So that would be your final answer on question or letter A on example 2. All you need to do is finish example B on question 2 on page 24. Again, if you can't write in your book, show your work below, and then show me these notes in class the next time I see you to earn your notes credit. I hope that this made sense to you. Please bring any questions to class tomorrow. I'm happy to answer them.